This is Pre-Calculus Concept 30A. We're going to look at some fundamental trigonometric identities. We're beginning a unit here on analytic trigonometry, which is basically all the relationships that the trig functions have to each other. And there's actually quite a few of them that you're already familiar with. So box 1 is actually 17 different formulas that you've already seen on how certain trig functions are related to each other. And we're going to break these down and look at them in groups and talk about some tricks to help you remember these identities. Alright, so let's start off with the reciprocal identities. These should look very familiar to you. We've been talking about them for the last several weeks. And I would hope at this point these are ones that you just kind of know. We do expect that you know each of these and the fact that cosecant is the reciprocal of sine and so on and so on and so on. Just a few ideas, or one idea in particular, to help remember, and that is that there come in pairs, and so hopefully when you think about these in your head or write these on paper, you kind of group them in this way. Sine and cosecant, while it's two different formulas, it's really a relationship, and each of those are reciprocals of each other. Same thing for cosine and secant, and same thing for tangent and cotangent. One trick people like to remember is that the sine goes with the cosine. One of them starts with S, the other starts with C, and the cosine goes with secant. So if that's a little way to help remember which goes with which, those are the 6 reciprocal identities. Alright, the quotient identities are basically what the tangent and cotangent are in terms of sine and cosine. You've seen these before as well, and hopefully you already remember these. But just a quick way to maybe help you is to go back to think about our unit circle. And in our unit circle, we talked about the fact that if your radius is 1, then any angle creates a point on the unit circle whose coordinates are cosine theta and sine theta. When you study the unit circle, we developed a bunch of these values. What you don't want to forget is that really comes from the idea of a right triangle. And if I think about the sides of this right triangle, one of the sides is cosine theta, and the other is sine theta. And so if you actually think about those as lengths of the triangle, we can go back to our right triangle trigonometry that we learned in algebra, actually in geometry, and the fact that the tangent is simply the opposite over the adjacent. And so in this case, the opposite would be the sine, and the adjacent would be the cosine, and that's a good way to remember where that formula comes from. To figure out cotangent, or to remember cotangent, you simply have to remember that cotangent is the reciprocal of tangent. So that's a good little useful trick. Think back to your unit circle if you're ever trying to remember what the tangent ratio is. Alright, there are 3 Pythagorean identities. These are the ones that people have the most difficulty remembering. But my tip to you is to think about the same thing I talked about in the last slide. And that is, really, if I think about a unit circle problem, I have a triangle whose hypotenuse is 1, whose bottom side is cosine, and whose top side is sine. And it should follow very logically from the Pythagorean theorem that the leg cosine, when you square that, and you add it to the leg that's sine, and you square that, you should get 1 squared. So that's really just an example of the Pythagorean theorem. Very useful way to remember that Pythagorean identity. There are 2 other Pythagorean identities that are a little less common, and I myself to this day use a little trick to help me remember. If you take the Pythagorean identity that we just talked about, sine squared plus cosine squared equals 1, and you divide every single term by a special value, in this case sine squared x, I actually get a new formula if I think about my reciprocal identities, right? The sine squared x over sine squared x is just going to be 1. Cosine squared over sine squared is going to be cotangent. We're actually this one over here, right? And finally, on the right side, I have 1 over sine squared, which is cosecant. So a quick way to get the third formula here is to take the first one and divide everything through by sine squared. Hopefully that makes sense. And as you might imagine, if I start over again, and this time I divide through by cosine squared, and cosine squared, as long as I do the same thing to all three terms, I'll get something equivalent. Sine squared over cosine squared is 1. Cosine squared over sine squared, sine squared over cosine squared is tangent squared, that one. Cosine squared over cosine squared is 1, and 1 over cosine squared is secant squared. So you can see how that little trick leads to the third formula. So ultimately you need to know all three of these, but what I wanted to show you here is that really if you know the first one really, really well, that's by far the most common one, by the way. The other two you can actually derive pretty quickly. Okay, and finally the odd-even identities. You hopefully recognize these. For this I like to go back to the unit circle one more time and think about the difference between a positive angle and a negative angle. In my picture here, once again I have 2 points on the unit circle. The upper point is going to be the cosine of positive theta and the sine of positive theta. And if I go down into the fourth quadrant, the coordinates would be the cosine of negative theta and the sine of negative theta. If you think about carefully which of those coordinates would be the same, it should be pretty apparent that the x-coordinates are going to match, right? Because the x-coordinates are going to be exactly the same thing. Which means that the cosine of negative and the cosine of positive are going to be equal to each other. So that's the example of the even function. Okay, and the reciprocal secant of an even function is also going to be an even function. So that's the one that's even. Okay, and again in my picture, if I think about the y-coordinate, it should be pretty obvious that the y-coordinate is going to be the exact opposite. So whatever y-coordinate I have up here, this one, since it's in the fourth quadrant, is going to be the exact opposite. Right? And so that makes it an odd function. And I think a helpful way to remember even and odd is just by thinking about a little unit circle picture like this. Okay, so that's 17 different formulas that you actually know already. We're going to expect you to memorize those and draw on those for future problems.